In this video, we'll look at numeric response questions. Numeric response questions are perfect for questions that require students to perform calculations. In addition to controlling the number format, you can also require units and specify the strictness of grading. As you will see, writing the text for the numeric question is similar to creating short answer or essay questions. The real difference comes when you write the answer and define the grading restrictions. This is what a numeric response question looks like on an online test. In this question, we're asking students to convert from centimeters to meters. Notice that for this question, students need to select the units for the answer as well as calculate the value. This is what a numeric response question looks like on a printed test. To create a numeric response question, we'll click the New Question button and select Numeric Response. First, let's type the question. Notice that a numeric response question has both an Answer tab and a Grading tab. Let's click the Answer tab first and look at our options. Next, we'll enter the answer. There are several options on the Answer tab. In the Response/Entry Mode section, you can specify whether the answer should be a regular number or a fraction. For fraction answers, students will have to fill in both the numerator and denominator. If you select fraction, you can also include a whole number field. If you select the regular option, you can choose to restrict the answer to contain only numbers. For this question, we'll accept the default. For our question, we want to require students to select the correct units. We can do that by selecting the Include Units requirement checkbox. There are 4 units available by default: feet, square feet, inches, and square inches. Our answer is in meters, so we need to add a new unit. Let's click Add to include meters in the list. We'll type meters and click Update. Since meters is the correct answer, we'll click the checkbox in the correct column next to it. When you select the unit as the correct unit, the checkbox in the After column is automatically selected. You can change that if the unit should appear before the number. This is what our question would look like online. There is a space for the numeric answer and a list of units. To get this question right, students need to enter the correct value and select the correct unit. The Grading tab allows you to specify the strictness of the grading. By default, the evaluation mode is set to arithmetic equivalency, which will consider answers correct even if they are written differently. For example, the answer to our question is 31.24. With the evaluation mode set to arithmetic equivalency, students could enter 31.240 and the system would accept that as a correct answer because it is equivalent to the answer. When you're using this setting, you can specify the number of decimal places as well as the number of significant figures required in the answer. When the second option is selected, students have to enter the answer exactly as it appears on the Answer tab. The third option makes the question subjective, so the system will not automatically grade the question. Students enter their answer and the question will have to be graded manually. For our question, we're going to require exactly 2 decimal places. We'll click OK to save the question. Notice that in the editor pane there is a note that our question has a special requirement. When creating numeric response questions, you can enter a range of acceptable values on the Answer tab. You can enter answer ranges as a simple inclusive range or a complex range. This is an example of a simple inclusive range. For a simple inclusive range, you enter the beginning and end of the range separated by an ellipsis, and both numbers are included in the range. In this example, an answer between 1 and 10, including both 1 and 10, will be accepted as correct. Let's see how a simple inclusive range works for students. In our example, the answer is a range from 1 to 10. Let's enter 1 and check our answer. The answer is correct. Now let's type 10 and check our answer. That's correct as well. Now let's type 14, which is outside of the range, and check our answer. That's incorrect, which is what we would expect because 14 is greater than 10. Now let's enter 0 to test the lower end of the range. That answer is incorrect as well. Next, we'll look at complex ranges. When using a complex range, use commas, square brackets, and parentheses to define the specifics of the range. Placing a square bracket to the left of the lower limit of the range or to the right of the upper limit includes the number in the range. In this example, we have a square bracket followed by 1, 10 and another square bracket. So the range goes from 1 to 10, and both 1 and 10 are included. So this is the same as a simple inclusive range that just uses an ellipsis. Now let's replace the square brackets with a parenthesis. The numbers next to a parenthesis are excluded from the range. So in this example, numbers between 1 and 10 are correct, but 1 and 10 are excluded. In other words, 2 through 9 will be marked as correct. Let's see how this works for the student. Notice that our question automatically contains a note that explains the range for students. Let's test it by typing 1 and checking our answer. That is incorrect because 1 is excluded from the range. Let's try 10. That's incorrect as well because 10 is also excluded from the range. Now let's try 2. That's correct because 2 is in the range. You can mix parentheses and square brackets. In this example, 1 is excluded from the range, but 10 is included. So the correct answer can be between 2 and 10. Let's try it out. First, we'll enter 1 as our answer. That's incorrect because 1 is preceded by a parenthesis and is excluded from the range. Let's try 10. That's correct because 10 is followed by a square bracket and therefore included in the range. And those are just some of the things you can do with a numeric response question.